The binomial theorem is a way to expand a binomial without having to write it down and multiply it out multiple times. The purpose of the binomial theorem is to speed up our calculations and make them more accurate because with less calculations, there's less chance for error. The binomial theorem says that if we have to expand x minus x plus y to the n, it would be x to the exponent, and then the coefficient becomes the exponent, x is raised to the power of the exponent minus 1, and then y is raised to the first power. And this continues until we get to the very end where there's no x's remaining and y to the exponent is our only term. Now, the main part of this formula is this one piece right here, because this is the generic formula for every piece within the term. It's NCR, where n is the value of the exponent, r is associated with its place in line, x to the n minus r means we subtract those numbers, and y to the r means that r matches up with the place in line. Now, in order to calculate NCR, your calculator has an NCR button. You can also do Pascal's triangle, which is usually what I prefer to do, or we can use this factorial formula. So it's n factorial divided by n minus r factorial times r factorial. In calculating our NCRs, we can also use this symbol here, n over r in parentheses. So we did these in class. So 5C2 is 10, 5C4 is 5, 5C0 is 1, 5C5 is 1. In looking at Pascal's triangle begins with row 0 because anything to the power of 0 is 1. So that's what turns a binomial into just one term. From there, we count down. So row 1, row 2, row 3, row 4, row 5. And you'll see that row 5 is the row with a 5 in it. You'll also notice that if we compare 5C0 is 1, that's the first term. 5C1 is 5, 5C2 is 10, 5C3 is 10, 5C4 is 5, and 5C5 is 1. If we need to expand x plus 2 cubed, the first thing we need to do is we need to get the third row out of Pascal's triangle. So that's the 1, 3, 3, 1. From there, we take our first term in the binomial, the x, and we put that to the third power, the second power, the first power, and then the 0 power. So the first term starts at the exponent and works its way down. The second term, the 2, starts at the 0 exponent and works its way up. So 0, 1, 2, 3. Our next step is we actually do the calculations. So this first term becomes x cubed. 2 to the first is 2, times 3 is 6, so this is 6x squared. 2 squared is 4, times 3 is 12. 2 cubed is 8. And then we write it out as a polynomial. So these were done by your classmates and put on the board. Notice the important thing here in this example is that the -1 is put inside parentheses because the exponent has to go to the negative sign as well. When you have a negative, what's going to happen is in your final answer, your signs flip-flop, negative, positive, negative, positive. Okay. Another example here, we have 2x to the fifth, so that gets put in parentheses, which gives us 32x to the fifth. Then we have 5 times 2x to the fourth times negative y to the first, so that's why it's a negative. 2 to the fourth is 16, times 5 is 80, and so on and so forth. Our next example, we had 3 to the fourth, the third, the second, the first, the 0 power, and then we have negative x squared, and that gets raised to the 0, the first, the second, the third, the fourth. So because of that, because it's originally x squared, all of our exponents on x are going to be even numbers, so 8, 6, 4, 2. And then once again, because it's negative, it flip-flops negative, positive, and you don't have to change the order. You can leave it in the order that it's given, 81 minus 108x squared plus 54x to the fourth minus 12x to the sixth plus x to the eighth. That's fine. If we only need to find a specific term of a binomial expansion, the way I like to do this is I need the fifth term. But remember, when we count with Pascal's triangle or with the combinations, we always start with 0. So the fifth term would actually be 8C4 because it would be 0, 1, 2, 3, 4 would give us the fifth term. This 4 matches with the exponent on the second term from the binomial. So I always fill that in first. So I do 2b to the fourth, and then I do 8 minus 4 to get the exponent for the first term. In doing those calculations, we end up getting 120 a to the fourth b to the fourth. Sorry, 1120 a to the fourth b to the fourth. In this case, we only want the coefficient. Now, this one, in a little bit of a different way, makes it easier than the last one, I think, because they're already giving us the exponents that we need to use. So if we look at it, our first term is 2a, our second term is negative 3b. Our exponent is 11, so that goes there. Because the b in our question has an exponent of 7 and a has an exponent of 4, I can put those in. Now that I've done that, I know that this 7 matches with this 7 here. So I can fill that number in. Now all I have to do is the calculations. So 11C7 times 2 to the fourth times negative 3 to the seventh is negative 11,547,360.